Hello, Honors Algebra 2. It is Wednesday, April 22nd, and we are on our last section of Chapter 13 on formulas for the tangent. Okay, this is it. We're done after today. So we'll have a quiz tomorrow on Thursday and chapter review, and then we will have our test on Monday. Alrighty, double angle. Let's start at the bottom with the addition formula for the tangent, the addition formula. So here we go. We've got two angles, alpha and beta. If we add them together, the tangent of the sum of those two angles is, and you can see the formula there at the bottom. At the top is the double angle formula. This is just like, finding the sine or cosine of 2 times an angle. Notice in the middle, the half angle formulas for the tangent. The nice thing is there's 3 of them. And to be honest with you, I prefer the second or the third one because I don't have to even think about the positive or negative value of the tangent of my angle. So you don't even have to think about what quadrant it's in if you use the second or the third. So that's kind of nice to have those 3 options there. Now, what we're going to do is we're going to go ahead and just do two examples here. And so I'm going to start with, let me get my pencil revved up here. I'm going to start with this top right here. Find the exact value of the tangent of 285 degrees. Okay, exact value, I think you know by now. That means that we are going to use our special triangles on that. Now, we want to find the tangent of 285. Well, 285, I could think of, can I think of 2 angles that add up to that value? And remember, we want to think about angles that are a multiple of 45 or 30 degrees so we can use our special triangles. Well, 285, you'll see below, I've already written it, is 240 plus 45. Both of those fit the bill. 240 is a multiple of 30 degrees and 45, well, 45 degrees, we know that one's going to work. So I'm going to rewrite 285 as the sum of 2 angles that I know I can find the values for. Now, over here, I went ahead on the right and I wrote down our formula here for the tangent of alpha plus beta. I went ahead and wrote that out. And so there is only one formula for that. And so let's go ahead and use it and get our answer here. Now, we want the tangent of 240 plus 45. And so that's going to be, okay, what have I got here? Something is going on, and let me fix that. Okay, I should be okay. All right, let's see. It's equal to, all right, now I'm good. All right, sorry about that. It's going to be equal to the tangent. Now, 240 is going to be my alpha. And so we're going to do the tangent, following my formula, the tangent of alpha, so the tangent of 240 degrees plus the tangent of, and 45 is going to be my beta, 45 degrees, all over 1 minus the tangent of alpha times the tangent of beta. Tangent of beta, and beta is 45. Sorry, that's my friend calling me. Actually, my middle son, David, who works at Mahoney's, is having a baby today. He and his wife are having a baby, so I've got lots of phone activity, so please excuse that. Okay, now let's go ahead and figure out what these values are. Well, 240 degrees, what quadrant is that in? Well, that's between 180 and 270, so it is a 3rd quadrant angle. So let's go ahead and create a reference triangle, and let's take 240 and subtract 180 and see what we get here. So 24 minus 80 is 60 degrees. Okay, so my reference angle is 60 degrees. Across from that would be root 3. Across from the 30 would be a 1, and the R value would be 2. So let's go ahead and, but remember in the 3rd quadrant, X and Y are negative. And that doesn't look like a negative. There's my negative right there. Negative. Okay. Now, so let's go ahead and write this in. The tangent of 240 degrees, well, remember, tangent is my Y over my X. And my Y is negative root 3, and my x is -1. And so the y over x is simply going to be √3. I'm going to add to that the tangent of 45 degrees. Well, let's just do that real quickly. 45 degrees is a 1, √2, and the tangent is y over x, and it's a 1. Okay, and down below I have 1 minus the tangent of 240, which is √3, and the tangent of 45, which is 1. And so what do I have here? I have here √3 plus 1 times 1 minus √3. Oh joy. Well, look what I have. I have a radical in the denominator. You wondered why you learned all that earlier. We're going to rationalize the denominator by multiplying by the conjugate. So let's go ahead and do that. And I'm going to use my parentheses here and see what I get. And so what I get here in the numerator is my first term is √3, my outer term is √9, which is 3, my inner term is 1, and my last term is √3. And then on the denominator, I have 1, outer and inner terms cancel, and I have a -3. Okay, I am out of room, am I not? So let's go ahead, and I'm going to go ahead now and erase this just so we can have some room here to finish this up. Okay, so here we go. So let's keep going. I'm going to go up here to keep going here. And so I have 3 plus 1. I have 4 plus, now √3 plus √3 is 2 √3. And in my denominator, I have 1 minus 3 is a -2. So let's just split this up, and I get -2 minus √3. That is the tangent of 285 degrees. -2 minus √3. Okay, now let's go down and try to find the exact value of the tangent of 5 pi over 12. The tangent of 5 pi over 12. Well, what I do is I first figure out what is that in degrees. Well, I multiply by 180 over pi, and I get 75 degrees. Huh. Well, I'll tell you. You could use the tangent of 75 is what? Well, you know what? I was thinking you could do 45 plus 30 degrees and use your same formula up here in blue that we used before, because 45 and 30 are special triangles. Are special angles in a special triangle. So, but just so we can use a different formula, let's go ahead and use the tangent of theta over 2. All right. Now, I went ahead and did that formula right here. The tangent of theta over 2 is the sine of theta over 1 plus the cosine theta. So what I'm going to have to figure out here is 75 is what angle divided by 2? Well, to figure that out, I'm going to double 75. And so I'm going to rewrite this as the tangent. Well, what's 75 times 2? 150. I'm going to write that it's the tangent of 150 over 2. And that's the same thing as the tangent of 75 degrees. Now I'm going to use my formula that I boxed in blue. And theta now becomes 150 degrees. So I'm going to do the sine of theta over, well, let me go ahead and do this. Let me go ahead and say that, okay, stop. I'm going to do the sine, theta is 150. Theta is 150. And then I'm going to do 1 plus the cosine of 150 degrees. Okay, now here we go. The sine of 150 degrees. You know me, I'm always drawing my reference triangle here. Okay, 150 is in the second quadrant, and if you do 180 minus 150, I get 30 degrees. Okay, so here I am. 30 degrees is my reference triangle. Across from the 30 is a 1. Across from the 60 is a √3, and the R value, the hypotenuse, is 2. Let's check our signs. In the second quadrant, my X value is negative. Y is positive. R is always positive. Well, the sine of 150 is going to be the opposite over the hypotenuse. So that's 1/2 in the numerator. In the denominator, I'm going to do 1 plus the cosine. Well, the cosine is going to be my x over my r. My x over r. And so that is going to be negative root 3 over 2. Negative root 3 over 2. And you say, well, goodness gracious, look at that. That's a mess. Well, let's use that special fun technique we used yesterday. Let's multiply by 2 over 2 and see what we get here. Well, 2 times 1/2 gives me a 1 up top. And then down below, I'm going to distribute 2 first to the 1 and then to the negative root 3 over 2, which gives me negative root 3. Okay. Now, oh, and by the way, the tangent of theta over 2, you got 3 options there. I used the middle option. I think the book used the third option, but you're going to see how we're going to get the same answer either way. Okay, now let's go ahead and multiply by the conjugate, 2 plus root 3 over 2 plus root 3, and I'm going to get 2 plus root 3 in the numerator. Let's look at our denominator. Okay, let's go ahead and FOIL that. 4 is the first term, outer and inner cancel out, minus 3. Well, isn't that easy? I end up with 2 plus root 3. 2 plus root 3 is exactly what the tangent of 75 degrees is. And you could put tangent of 75 degrees in your calculator, and yeah, you get a decimal approximation, but 2 plus root 3 is the purest of forms of the value of the tangent of that number. It's exact. It's exact, using our special triangles to figure all that out. Okay, well, how about it? You're going to be doing some homework. You're going to have a self-test and maybe some mixed review. I haven't assigned the homework yet, but you'll see what it is when you get there. And come see me at Zoom if you need me. And then we will have a quiz on Thursday and chapter review. So Thursday you won't have a new lecture. And you're like, oh, thank goodness. Okay. All right. Have a great day. Y'all have been doing great hanging in there. I'm really proud of you guys. So I will see you, maybe see you at Zoom, but definitely, and I won't talk to you tomorrow, but I'll be back, and we'll see you Monday. Monday's test day. Oh my goodness. Well, chat with me if you need to, or come to Zoom if you have a question. Bye-bye.